I thought I'd start off with a cute cartoon. Why statisticians don't make it as waiters. Hi, sir. I normally distributed the butter on your toast this morning. That's not that normal. But, anyways, we're going to do hypothesis test to compare proportions. So we've already done confidence intervals to compare proportions. Now to the hypothesis test. So say I bought a 5-pound bag of M&Ms, which has a total of about 2,400 pieces, and I want to check the proportion of green. That's my favorite color, although I do like purple as well. And I randomly sample 200 M&Ms. So like I stir and I pull 200 M&Ms and I count 36 green ones. Then a few weeks later, I go ahead and get another large bag. And this time I'm feeling a little lazy, so I only pull 100 M&Ms randomly, and I get 16. Do I have enough evidence to conclude that the proportion of green M&Ms is lower in the second bag than the first? So, if we're doing a confidence interval, what would we do? We would look at the difference of the two proportions, and we're going to start that way as well here with hypothesis testing. So, for when we're performing a two-sample z-test for p, based on what we did with the confidence intervals, the hypothesis, we do the difference, and we say, oh, it should be 0. Now, you could also write it as P1 equals P2. I like this form because it's normally, that's what we're using for the z-scores and everything. Now, if based on this first form, our alternates would look like either P1 or minus P2 isn't 0, it's greater than 0, or it's less than 0. So those are your alternate hypotheses. And remember, this is what we use to shade in the normal distribution. All right, this is over. Okay, we're going back to my candy, and we're going to complete the state. So I want to do the null hypothesis and the alternate. In this case, I'm saying that the first bag is higher than the second bag. This is a little tricky because you got to remember what's what, and I'm concluding that is there enough evidence that I can say P1 is higher than P2 or P2 is lower than P1. So P1 minus P2 is greater than 0. Can I go P2 minus P1? I could. I just need to make sure this makes sense for whatever I'm subtracting. Don't forget to say what these proportions are. So P1 is a true proportion of green M&Ms in the first bag, and P2 is the analogous proportion in the second bag. My population on each of these is actually 2 different bags. It's not a sample because I sampled the large bag. So similar to the confidence interval, we check the same 3 conditions, random. State if it's assumed or given. It could representative also counts. Large counts, successes and failures both need to be greater than or equal to 10 for both samples. 10% is less than 10% of the population unless there is no replacement, in which case this condition isn't an issue. All right, so we're going to complete the plan. I'm doing a 2-sample z-test for P. Random is given. Large counts, I counted 36 green in the first bag, which means 164 were not green. Those are both greater than or equal to 10. 16 green and 84 not green, so that's fine too. And both samples are less than 10% of the M&Ms in both bags, so the conditions have been met. And I could probably write that on here. I probably would if I